Good.
All right. Yeah, hello everyone, and thank you very much, Asio, for the invitation. So I'm going to talk a little bit to you about SSSOM, which is a standard for representing simple entity mappings. And so for those of you, so this is a abbreviated talk from one that is a little bit longer that you can check out if you want to on this slide. I think, Asia, if you want, you can also share the slides later with the rest of the people, so if they're interested in anything specifically.
I will. Thank you.
All right. Okay, so just for setting a little bit the scene. So let's consider like a kind of scenario where we have like a bunch of organizations, institutions generating data separately, which are typically in the beginning just generated in their own sort of space and depicted by these silos. And then a situation where that comes eventually, hopefully, if you are working with the right grant agencies, where people are encouraged to start with a process that for standardizing their data. So that let's think about a kind of scenario where all of these institutes are somehow describing anatomical data, and now they are sort of encouraged to standardize their anatomical data according to existing standards that are out there. But because this is a sort of bottom-up process, what usually happens is that some organization somewhere on the planet will adopt one standard. So in this case here, for example, the Uberon anatomy ontology, which is depicted here on the right, which is like a controlled vocabulary, in case you don't know it, that describes the anatomical entities and their interrelationships. And you may have in a different part of the world someone adopting a different standard, for example, the foundational model of anatomy, and yet another part, for whatever reason, maybe these two ontologies didn't work for this organization, or they simply didn't know about it. They just started building their own anatomy ontology. And we see this over and over and over again, that these kind of semantic spaces are sort of emerging when they are emerging in a bottom-up scenario, that actually, the standards that they're using, especially, I mean, Asia, you know this very well in the disease world, like very different groups adopt different disease ontologies. And this is just a very realistic view of what's happening at the moment. So this kind of idea and this hope that we, especially if you're familiar with the kind of vision of semantic web and some of the kind of ideals that we were communicating as part of our work of the OBO Foundry, which is an organization that is dealing with trying to harmonize ontologies in the biomedical domain, this kind of idea that all of these organizations will eventually see the light and see that there's this one awesome standard, Uberon, and we will all swap our pipelines, our curation, our data descriptions to using that pipeline. That is basically not realistically going to happen. So we will somehow stay in a situation like this, where we have different spaces, we call them here semantic spaces, that are described using different kind of controlled vocabularies. And if we have, for example, so one of the problems is of course that even though there are different semantic spaces, we still have a lot of use cases in which we need to sort of bridge across them, and we need to integrate across them. So this is a seemingly simple question here, which is how many rare diseases are there, which has been tried to be answered by in many different works. But one thing that, of course, there are some other problems with this question, but one thing that is very and that becomes very clear is that only a small fraction of the terms that we consider rare will be covered by by a bigger number of relevant controlled vocabularies, while a large number of terms are actually covered only by a single vocabulary. So if you want to do something like, just tell me how many diseases, rare diseases are there? Are there 10,000? Are there 12,000? Are there 8,000? Then you can't just look at one of them. You have to look at all of them. and you have to somehow have them integrated together in order to get that kind of count. And similarly, if you, like, this is one of the use cases that we are pursuing a lot in our domain. Here, this is an example from a collaboration between the Monarch Initiative and Critical Path Institute, where we want to integrate rare disease registry data in a big knowledge graph that covers all of these disease concepts. We want to have it somehow possible that if you have like built a knowledge graph like this, where you have all these anatomical concepts, the disease concepts, and other concepts being represented. Of course, we ideally, so that we can use this usefully, want to have that one blob in this knowledge graph is referring to exactly one disease, and not that there are like lots of different nodes in here that represent the concepts from all these different resources, like, for example, we said before, OMIM, ORPHANET, or NCIT. So what we do need is we need to build mappings across these semantic spaces. All right, so what do we mean by mapping exactly? So this is another like big problem in all discussions and all dialogues. Basically, when there are 3 people in the room, there are 4 opinions about what exactly a mapping is. And I don't want to discuss here exactly, give an exhaustive definition. I just want to emphasize 2 very important different mapping types of mappings, which are entity mappings, which I just loosely define here as determining and documenting the correspondence of an entity, such as a disease, an anatomical entity, and so on, in one semantic space to another. So we've seen some examples from Uberon, and you could imagine a mapping between Uberon and FMA classes, for example. And as a second type of mapping is schema mappings, which is about determining and documenting the translation rules for converting an entity or a data structure from one semantic space to another. So these things are very different, and what we are concerned with today here is the former. So we are just considered with the more simple problem of entity mappings and not with the problem of mapping across data schemas. We have a workshop in 2 days that if one of you or some of you are interested, you can join remotely. This is happening in person at Biocuration here in Italy. But we will discuss this case a little bit here and delineate it from the SSSOM use case. All right, so what is an entity mapping? So basically an entity, entities are symbols such as codes in a terminology, classes in an ontology, enums in a data model, or simply strings in a text field that are intended to refer to some real world thing. So you may have like a data set from an old record where you have like a string Friedrich's ataxia somewhere in a cell on the one side, and you have on the right side a Excel spreadsheet where you are using, let's say, an OMOP identifier that refers, and both of these kind of symbols here, the string on the left and the identifier on the right, they both refer to the concept of Friedrich's ataxia. So that's kind of the essence. And when we say, and what is an entity mapping, it's basically a link from one of these symbols to another. So there are different types of entity mapping. So there are entity mappings of this type 1, where we have a mapping between a lexical token, for example, as a consequence of named entity recognition algorithm or something like that, to a controlled vocabulary identifier. So this is sometimes called grounding as well. Then we have the type 2, which is mappings from one identifier to another, and we have complex mappings, which is the case where you have like one term in one semantic space, terminology, controlled vocabulary, that is basically a post-coordinated description of multiple, often complex, interlinked terms in another semantic space. All right, so the problem with like current mappings out there is for example, their lack of semantic precision. So we have when you're looking at something like OMOP, which is one of the kind of like better resources out there, actually it's a quite great resource for us now, you can see that the way that they are encoding mappings is using a simple maps2 relationship. And while maps2 may be okay for something like amoebiasis in ICD-10-CM to amoebic infection, it is definitely clear that if you look at a refractory anemia with multilineage dysplasia, that this is a more narrow term than the refractory anemia. So now if we want to do something simple like just look at the first 2 rows, count how many different diseases are we talking about, it's going to be difficult with using these two relationships, because you look at this and it's like, okay, is it 2 diseases, is it 3 diseases, who knows, like conceptually. And there are many other kind of more complex mappings that exist, of course, in mappings, and it seems very like insufficient to just use a simple maps2 relationships for all of these. Another problem is that the mapping space is enormous. So we have the more semantic spaces are out there, like disease ontologies, disease terminologies, and so on, the more possible links we have between them, and the more kind of mappings we have to create. So there are lots of combinations and a lot of mappings that may be necessary, and there's also now starting to be a proliferation of these like hub and spoke solutions like UMLS or OMOP or Mondo, where you try to create like one central integrated term and link it to all of the other ones, and link all the other ones into that centralized ID space. And it's also clear, and most of you that are involved in mappings know this, that curating good mappings, especially in our domain, in the clinical domain, is very, very difficult sometimes. Yeah, so even if you have like terms that have the same exact label across different terminologies, it's not even 100% clear whether they are supposed to be referring to the same exact disease, because they are, for example, classified in entirely different branches of the ontology. So it's a really hard problem. And obviously, yeah, good mappings are a moving target. So with every release of a source vocabulary, mappings can change. And yeah, it's a I think the point got across. So it is clear mappings are super important, but there are really few very good mappings because we need expensive expertise. So the space is huge. Mappings are subject to constant change, and mappings are fit or unfit for purpose rather than good or bad. And fitness for purpose is really difficult to assess and implement. So our kind of like tenet was somehow we could do better. We can share mappings across the whole communities to avoid creating the same mapping over and over again. We can maybe enrich the mappings that we have with metadata that allow us to reuse the mappings across purpose, and enable the combination of mappings from different resources, and maybe build a decentralized effort similar to what the OBO Foundry was doing with ontologies, that where mappings can be shared across organizations. So the basic idea is society, the taxpayer should not have to fund this incredible level of duplication of effort that we have right now creating mappings. So how does like a simple mapping look like in the SSSOM sense? So of course we have this sort of kind of triplet of subject, predicate, and object. The subject can be described with various different metadata items, in particular, like for example, a label, an identifier. The predicate is a very important part, which is describes the semantic relationships that should hold between the subject and the object, and we will get to this in a second in a concrete example. And then the other very important piece of like the SSSOM kind of basic design is this idea of a justification. So we should be able to justify one mapping somehow, to say, for example, we have determined this mapping based on a lexical matching process, or we've determined this mapping based on a clinical expert that reviewed this and determined this mapping. The SSSOM file itself looks very simple, so this is another kind of important part of the design, is that it should have been possible to express the mapping as a simple table. So you can see it basically looks like a very straightforward to read table with object ID, predicate ID, so this and some other values like confidence, the justification, some metadata. And then there's also the possibility of recording mapping set, so groups of mappings, metadata, and the header of that TSV file. And there's a standard formalism where how you can do that, providing information like licensing and so on in the same file as the mappings, which makes these things a bit more glued together when they are shared around. So the big design features of SSSOM is, for example, these with one of the key bits is the semantic mapping predicates. So one thing that we can use and exploit when we are building mapping sets where we have semantic mapping predicates is we can drop cost drastically by exploiting the semantics of those mappings relationships. So for example, we have, let's say, this orphanet to Mondo exact match and the Mondo to ICD broad match. That is something we know. Then we can use walkback, so symmetric walkbacks, to say, okay, if orphanet is mapped to Mondo, then the Mondo term is also an exact match to the orphanet term. Or we can have like an inverse walkback. So if the Mondo term is a broad match to the ICD-10 term, then we can infer that the ICD-10 term is a narrow match to the Mondo term. Or we can do other cool things like building mapping chains. For example, in this case, orphanet is a broad match to this ICD-10 term through the Mondo intermediate. The mapping justifications are basically these, so you can have multiple ones. So this is just two examples. So this is an example of a justification for a lexical match. So you can imagine you have a big tool process that is running, for example, automated matching between two terminologies, and they can record things like on what field in the data model did the match happen, what was the string that was matched, what was the pre-processing that was that happened prior to the matching. And for example, for manual curation, you can record things like confidence, who did it, and so on. And all of this information will allow basically another person reusing your mapping to be able to decide, am I going to trust this lexical match? No, I'm not going to trust lexical match. I only trust, let's say, manually curated mapping. So they have a natural way to filter out all of the ones that are automatically created, for example. All right, and kind of one big idea is that when we are building, so right now mappings are kind of created a lot inside of big ETL processes that are not really shared very much. They may be exposed somehow in APIs, but they are not shared in the strict sense. So one thing that what we hope to achieve is that creating kind of like a network of these kind of mapping registries and mapping commonses that can be shared, for example, as part of a GitHub repository, and then can be imported from across. So you can import, let's say, one mapping set from one mapping commons into your mapping commons, reuse it, combine it, and also exploit shared tooling, like, for example, automated reconciliation approaches that weed out conflicting mappings with some probabilistic algorithms and so on, or even just for collaborative curation, like a user can just say, look, this mapping is wrong, please fix it, or even just fix it themselves. So the idea then is that you have multiple of these mapping commonses, mapping registries out there that could be manifested, as I said, as GitHub repositories that store multiple mapping sets. And then we have mapping servers that can go and make these things available, like the mapping sets from various different registries, and make them searchable for the wider community. So we are building, for example, a mapping server now at the European Bioinformatics Institute that will index a bunch of different mapping commons that are out there. All right, so I'm getting to the end now. So in terms of like what efforts are there with regards to SSSOM in the kind of wider clinical domain. So We have some ongoing collaboration with Odyssey and some of the OMOP members of the OMOP ETL development. So we have, in particular, this is all like, none of this is like, fixed or anything. So this is just like exploratory state, but we are looking into representing the mappings that are created during the OMOP vocabulary ETL, looking for representing ETL conventions and just concrete flow sheet mappings using SSSOM, and we're working with the Odyssey, with various members of the Odyssey group to achieve this. There might be even another workshop. We've done a workshop last year. There may be a workshop in Rotterdam in July about that as well again. Fire, some of our groups are involved a lot with Fire, so there's at least plans to have like a concept map profile that is enhanced with SSSOM metadata. And there are some tooling that are already implemented for converting at least from SSSOM to Fire. And yeah, there are various semantic mapping efforts that are going on between some of these like rare disease resources like OMIM, Orphanet, DO, and Mondo as part of the Monarch initiative. And the big thing that we are working on at the moment is figuring out how can we represent these complex mappings, which is the subject of the Sunday workshop. All right, yes, thank you very much for your attention. This work is primarily funded by the Phenomics First grant, an NIH NHGRI grant. It has had some contribution by Monarch, so another NIH grant, some Bosch gift to Lawrence Berkeley, and a Young Faculty Award grant from DARPA. And this is the team on the right side, and I've highlighted some of the newer members. And if any one of you, of course, is interested to get involved in this effort, or is generally interested, we are very happy to onboard you and involve you in the development. So yeah, that's it. Thank you very much.